All right, you figured out how to make a sample. You figured out how to collect the data. You figured out how to display it, but there are some other ways to display things. Okay, so section 2, page 1 of chapter 11 is picturing data. We're going to talk about some bar graphs, some histograms, some polygons, some time series graphs, and some pie charts. Okay. Presenting the data you collected at a meeting, you want it to be visually appropriate. Okay, people should at a glance look at it and understand what happened with the data and your results from it. Okay, so bar graphs are mostly for large amounts of data, where you can group them together and put some horizontal or even vertical bars together. See how long they are compared to the other bars in classes. Let's see, it says the length of the bar represents values of the variable being displayed, the frequency of the occurrence, and the percentage of the occurrence. Okay, all the things we did in grouped and categorical frequency distributions. Okay, histograms are specific things called a type of bar graph that displays the group data. Okay, typically you won't see any spaces between the bars. Given your technology, though, sometimes, like if you're doing a bar graph in Excel, you're going to get gaps in between. It can't be helped. They're not really histograms; they're regular bar graphs, but if you were to hand draw a histogram, you wouldn't put any gaps in between the bars. Okay. All bar graphs have titles as well, labels, and a representative scale, horizontally and vertically. Okay. Frequency polygons and time series graphs are lines, not bars, and obviously a pie is a round thing. So let's look at some of these and interpret some of these. Okay. You should be able to look at the graph and understand what's going on in the graph. Let's take A here. Causes of inventory shrinkage. This is a categorical frequency distribution, and it has bars that are vertical bars, and you can see it's categorical because of the categories on the x-axis is the horizontal axis. And there is my x-axis title. Okay, these are my categories for my frequency distribution. Okay, and then over here is my y-axis. Okay, and you can tell it goes from 0 to, they went up by 2s. You can decide the scale on this side, go up by 5s, go up by 20s, go up by 1s. This is up by 2s, and the tallest one is what, about 15? This one is, well, I don't know, it's looks like 15 and a half, maybe. This one kind of goes up to maybe 15. It's a little shorter. I mean, I'm taking a guess here. I'm going back over here. This is like 7.9 or something. It's just a visual representation with a, that looks like a 3, with kind of an idea of the causes of inventory shrinkage. Employee theft seems to be number 1. Shoplifting is next. Admin error is next. Vendor fraud. So these are things to look out for and prepare for when you own a business. And this is actually put in descending order. I think it's Pareto chart, but you don't need to, it's a bar graph. Okay. So you can see that right here is the main title of the graph to tell people what they're looking at. So all these things are required, and you need these scales where appropriate. Okay. So let's look at B here. I should probably not move it. I don't know if you can read this. This is kind of really small. That says Wendy's, KFC, Pizza Hut, Burger King, Subway, and this says worldwide sales. It's a little small for people across the room. I may have shrunk that to stick it on this thing, but these should be bigger. And right here is the y-axis title that says dollars in billions. Okay, and down here, if this says company. Okay, so this is a horizontal bar graph. All right, and you can see the scale on the x-axis instead. And that's a 16. It goes up by 2 this way. And clearly KFC has the biggest worldwide sales. Burger King following, then Subway, then Pizza Hut, then Wendy's. So I don't know why there's no like McDonald's on there, but it does have axis labels, it does have a title, and it does have scale where necessary. Okay, so you get that what's going on there. This one is missing its title. I must have chopped it off, but let's see if we can make one up. It says number of states here, and because the highest value only came to here, we don't put all the states. We just stop wherever we need to make sure we're including this. So this scale goes up by 3. This says temperature. So I don't know, average temperature in the US states, maybe should be the title. Because then, and this doesn't tell me if it's in Celsius or Fahrenheit. So these numbers are kind of strange to me. So maybe it's in Celsius instead of Fahrenheit. But this is called a frequency polygon, because remember the polygons in the time series are lines, not bars. So this is clearly a line, and the frequency polygons always start at 0. If you have to make one in Alex, they put the scales there for you. You're just moving the line around, okay? They have to start on 0 and end on 0. And it looks like most of the states have this temperature here approximately. So that must be the most common temperature in the states. Approximately 112. I'm thinking Celsius instead of Fahrenheit, but that's what a polygon looks like. And then this one over here is clearly a histogram. Notice the midpoints. Oops, this does have a title. Prices of GPS navigators labeled with class midpoints. Okay, put them all together. Make sure you have the frequency, number of GPS navigators at these prices, because we're not starting at 0. For the x-axis, there's a broken axis here kind of going right to the numbers that we need, and then there's a scale from here that's equal distance. This is up by 2s. Apparently we don't have a frequency above 8, so it was fine just to go to kind of finish at 10. And clearly right here is the most common price range, right? These are class midpoints. So price range, this is a grouped frequency distribution. Okay, grouped frequency distribution with the numbers. Okay, these are the midpoints, most common price, because 8 different ones had this average price that fell in this class. Okay, there were some expensive ones up this end. These were kind of the more expensive. There wasn't that many of those. Seems like most GPS that you would buy is down here. This is the lowest cost class. Okay. So just information that you can get from a graph. I want to skip a page and go to page 3 to look at that time series one. And I'll come back to the pie charts. Time series have their time along the horizontal axis. Don't put it anywhere else. Okay. Time. It could be years, could be minutes, could be hours. Time is more, years is more the average. Okay. This is cellular telephone subscribers. In the millions is the scale. It goes up by 25. And it says the data set's composed of numerical entries taken at regular intervals over a period of time. So these are the number of subscribers going up. So this is a good thing. Over time, this is nice to show the company. Each dot is a paired data set. So the year that it was taken, the number of subscribers it goes with. Okay, so these are dots. So this right here was the first data point was, I'm taking a guess, about 74. And sorry, the year goes first, right? X always goes first. This is the X axis. This is the Y. So the year was 1998. And then this looks about a 74 for this data point right here. Okay, you kind of go across this way and down that way to read these. Okay, this is my X, this is my Y. Always, always, always. So what's on the horizontal goes first. So like this one here, if you follow it over, follow it down, this is 2002 and I don't know, 35, 40, maybe 140, guessing. Okay, it'd be a little clearer if I had different graphs. But that's what a time series looks like. And there are steps on the bottom here for constructing a histogram and a frequency polygon. You want to make sure you're getting your axis, your horizontal x-axis, your vertical y-axis. You create a scale for the years. That covers all the midpoints for a polygon. For a histogram, you can use midpoints or class limits, like on each side of the bar versus the middle of the bar. On the x-axis, the scale has to start at 0 and then covers to the highest frequency. And number, keeping the drawing a reasonable size. So this one goes up by 25 to get it all shoved into a reasonable size. Plot the frequencies for each class. Okay, and draw the vertical bars for a histogram and lines for a polygon. Remember, the lines for the frequency polygon begin and end on the x-axis, and the histogram technically should have no gaps between the bars. It says in the Alex homework, the scale for the x and y-axis is completed for you in most cases. Okay, I think you'll find them quite easy. For the project, you have to make your own. So if you're doing a statistics project, okay? I will come back and do the pie chart in its own video for page 2.